Hello, Selena and I are back to share more area fun with you. You know, I said last time area is some of my favorite work because it's kind of like putting together a puzzle. And so today we're going to talk more about area of triangles. We talked about area of triangles last time. We talked about area of acute triangles, and today we're going to talk about area of a right triangle. Remember, right triangles are triangles with one right angle. Okay, so I'm going to switch us into the other view so you can see. And here I have two right angled triangles. I just set them both out next to each other so we could compare them. I know I always tell you you can trust the materials and you can trust me, but we should always check anyway. So here I have a right angled triangle, and we're going to check it here. That rectangle, or did I say rectangle?
Yes, you did.
Okay, no, that this triangle is same shape, same size as the triangle underneath. It's not a rectangle. Okay, so what is our first method for finding area? What's the first way we always did to check?
Base times height.
Oh, no, that's not the, no. The first way we did was easier than that.
Oh, we counted all the squares.
We counted every square, but do we have complete squares when we look at this triangle?
No.
We don't have complete squares, so we can't use that. So then she was saying base times height, which is specific to rectangles, yes. But we just decided we don't have rectangles here, we have yes. Triangles here. So maybe she was thinking ahead to the fact that she knows that we know the area of a rectangle, and so if there's a way to convert these triangles into rectangles, then that would help us solve for the area. So Selena, is there a way that we can transform this divided right triangle into a rectangle? Interesting. Okay, I'm going to put that back and let's look at this. Selena took this piece off of the side over here and she glued it on or moved it up to the top. Interesting. Okay, so let's look at the triangle we started with. Let's find the base of this triangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The base is 10. What is the height?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
This right triangle has a base of 10 and a height of 10. When she transformed this into a rectangle, she now has a rectangle with a base of
1, 2, 3, 4, 5.
Interesting. And a height of
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, the height stayed the same, but the base is now only 5. The base is half of your triangle. Interesting. Let's write the formula for what we just discovered. Selena discovered that the area of this triangle, should have drawn it as a right triangle, there you go. This area of this right triangle is equal to half of the base times the height. Half the base times the height. Interesting. I was very curious. Okay, we're going to set that one right up there. Now let's see about this right triangle again, because we know that when we did the acute triangle, we had 3 ways of solving it. So let me see. Can you hold on to that guy? Okay. Here I have my right triangle reconfigured, and we're going to set this one down. And we didn't play a magic trick. It's still congruent, still same shape, same size. But now we're going to convert this triangle over here into a rectangle. What can we do to make this triangle into a rectangle? Ooh, she broke off the top this time.
That's the only way it breaks off.
And she's gluing it on the side. Last time she broke off the side and glued it on the top. This time she broke off the top and glued it to the side. Okay, let's find out what our base and our height are. What's the base of this rectangle?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
No, it's still the same. Okay, let's count over here.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah, the base stayed the same. Okay, we know that the height of our triangle is 10. What's the height of our rectangle?
1, 2, 3, 4,
5. Okay, so we have a rectangle with a base of 10 and a height of 5. Base of 10, height of 10. Interesting. So what is the height difference here?
It's half.
Oh, so the area of this right triangle equals the base times half of the height. All right. There's two ways to find area of a right triangle. Okay. When we did area of an acute triangle, there were three ways. And the third way was interesting. The third way, we combined the pieces. Can you combine these pieces into a figure that we can find the area of? Ooh, nice. She took our two triangles and stuck them together along their hypotenuse.
I love that word.
I know, that's a fun word. That's why I wanted to say it, because we did parts of a triangle the other week. So that's all fresh for us. Okay, so here we've combined both of our triangles together. What is the base, or what is the shape that we made?
A rectangle.
It's a special rectangle because its base and its height are the same. Its base is
10.
And its height is 10. So if we were finding the area of this whole space, we would do base times height, 10 times 10.
100.
It's 100. But we're not trying to find the area of the whole thing. We're trying to find the area of just this part. How much of this whole shape is this part? Half. Oh. So if we did base times height for the whole area and then divided it in half, it would give us the area of the triangle. The area of our right triangle equals base times height divided by 2. This is really curious to me, Selena.
Sounds like Alexander.
The other day, we did this exact same work with 3 other triangles, the acute triangles, and we learned something different. We learned that the acute angle triangle has 3 formulas for finding the area. Let me see if I still have my little tickets. The area of an acute angle was half the base times the height. And the area of an acute triangle could be base times half the height. And we also learned that the area of an acute triangle was base times height divided by 2. Are you telling me that we can use any one of these 3 formulas to find the area of any acute or any right angle triangle? There are 3 formulas for finding the area of an acute and a right angle triangle. Half the base times the height, base times half the height, and base times height divided by 2. Okay, so that's just weird. All right, do you want to see, we have one more kind of triangle to do, the obtuse angle triangle. Shall we go ahead and just do obtuse right now?
Yes.
Okay, let's move our acute or our right triangles off the mat.
Bring the mat with it.
And I'm just gonna stack these guys up and set them a little bit off the screen just so that we can have some room. Here I have an obtuse angle triangle.
It's big.
It is big. This is the base of our obtuse angle triangle. Let's count it.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I love these triangles with 10 on the base. Now, here's something tricky. When we were talking about parts of a triangle, you did this in the other day in a lesson. Parts of a triangle, when you have an obtuse angle triangle, you can't measure the height along this side because that's a side, not a height. The height is measured from the tallest part with a vertical line down to the base. So the height is actually here. I have our trusty rectangle out to put it right there for you. So the height is from the tallest point down to the base. And so what is the height of this triangle?
10.
10. Yeah. Your angle is a little funny, but there we go. So 10 from the top point to the base. We call that an external height. The height is outside of the triangle. Okay, so here's an obtuse triangle. And then I have a divided obtuse triangle. I wanted to get it set before I brought it over. It has lots of pieces. Like I said, it's like a puzzle. Okay, I do have to keep you tilted a little bit, not straight on for this. Okay, so I'll show you that they're congruent, same shape, same size. It has a base of 10, same base, has a height of 10, same height. Okay, so Selena, the obtuse triangle is hard to manipulate, but is there a way that we can convert this obtuse triangle into a rectangle that we can find the area of? She cut the top off and glued it on. Oh, hold on, what's this shape?
The slanty thing.
It's a figure, it's a quadrilateral with two pairs of parallel sides and no right angles. It's called a parallelogram. We know how to find the area of a parallelogram. The area of a parallelogram is the same as area of a rectangle. Base times height. But guess what? This parallelogram is really special. We can actually make it into a rectangle. Again, base times height. Okay. Here was our obtuse angled triangle. Did our base change?
No.
Our base stayed the same. Did our height change?
Yes.
Our height started out as 10 and it is now 5. The height of our obtuse triangle is half. Base times half the height. Does that sound familiar?
Yeah.
Yeah. So base times half the height. Do you think if we had turned this the other way and you broke it off and put it the other way, we could have broke the base in half? Yeah. And I want to show you just really quickly that if we had started with our obtuse triangle like this, and we added on another obtuse triangle at the top, what is the shape we get?
A rhombus.
A parallelogram,
Parallelogram.
which we know how to find the area of.
Yes.
Base times height. And we're only looking for half of it, so this would be base times height divided by 2. Interesting. It doesn't matter if you have an acute, a right, or an obtuse angled triangle. You can use the same formula for any triangle you encounter. Let me show you those formulas one more time. You can take half of the base times the height. You can take the base times half the height, or you can take the base times the height divided by 2. You might be wondering, why would you ever need to know all those different formulas? Sometimes it's easier to take half of the base. In ours, our base was always 10, so it was easy. Half of 10 is 5. But if your base was 7, you wouldn't necessarily be able to take half of 7 easily to multiply. So in that case, you'd want to leave your base the same and take half of your height. So there's lots of reasons why you would want to find area of a triangle with these different ways. My favorite go-to one is base times height divided by 2. That just seems to be the easiest all-purpose one for me, but I want you to know there's all 3 of these ways to find area of a triangle. In your journal, you're going to have a place for area of a right triangle, and you can also add obtuse to the same page. Last time you did area of an acute triangle and you showed all 3 of those ways. You don't have to show all 3 of the ways. And area of an obtuse triangle. You do need to show me the formulas. We know that area of a triangle equals half of the base times the height. Area of a triangle equals base times half the height, or area of a triangle equals base times height divided by 2. And on the bottom of your page, you're going to draw me triangles on your graph paper. Let's say 5 triangles. I want you to draw 5 triangles and find the area of them on your graph paper. And you can use whatever formula you want. I want you to try at least one each way, and then you can pick which way is best for you. But I want you to try one each way. Make sure you're showing your math so I know which formula you use. All right, thank you. We'll see you next time.